300 years ago, in the 17th century, the Mughal Emperor Shah Jahan built the Taj Mahal as a mausoleum for his wife. 20,000 men labored for 22 years to construct the structure, which is one of the 7 wonders of the world. This year, we focused on a simple question. Could we recreate the Taj Mahal using the techniques of DNA origami? So, in our project, we shall look into various DNA origami techniques for modeling the Taj Mahal. So, let's start with the basics. Origami is the traditional Japanese art of paper folding. DNA origami is the folding of DNA to create 2D and 3D shapes at nanoscale. In 2006, Paul Rothman first developed this idea and described it in his article in Nature. Let us tell you how DNA origami works. A single long strand of viral DNA is folded into desired shapes using many smaller strands as staplers. When we mix the template strand and the stapler strands together in an appropriate environment in the lab, they self-assemble to form desired shapes. Initially, we designed some 2D DNA origami structures using available CAD software. For example, here is a map of Gujarat, a state in India, designed on CAD Nano software. We used M13 scaffold as a template for creating the structure. In February this year, the famous DNA robot was designed using multi-layer DNA origami. Castro and group described the procedure in their paper, A Primer to Scaffolded DNA Origami. We decided to replicate this technique to create the 3D Taj Mahal. We used CAD Nano again and successfully designed the structure and generated its stapler sequences. In April this year, Hao Yan and group developed a technique to create curved 3D DNA origami structures. Since Biomod encourages us to think and develop new biomolecular design techniques, we tried to extend the technique to scale up 3D DNA origami structures. We first created a master plan of the 3D Taj Mahal on Autodesk Maya and constructed individual structures for the design on Nano Engineers. Then we provided concentric rings around the base of each structure by extending its scaffold. After this, we provided stapler strands across the extended bases of the structures and also ensured that all the structures lie in the same plane. However, this technique still needs experimental validation and scaling 3D DNA origami is still a challenge. While working on the project, we felt it would be good to introduce automation in the DNA origami process. We introduced ConCAD, an interactive computer-aided designing software. ConCAD focuses on prototyping, rendering, and analyzing structural details of DNA origami objects. It ensures that the rendered structure follows standard designing principles to ensure maximum theoretical stability. Finally, summarizing our project. We started with 2D DNA origami structures. Then we moved to single-shape DNA origami and designed the Taj Mahal successfully. To scale up and improve the resolution of the structure, we proposed various multi-shape origami techniques. And finally, we introduced our CAD software ConCAD. Thank you for watching the video.